In this tutorial, we'll learn how to use the Document Term Matrix plugin for the Butter text analysis software. What this plugin will do is take a frequency list that we've generated from a corpus and use that information to help us build a document term matrix, which is essentially a table that tells us in the rows which documents exist and in the columns which words are present within each document. Now this plugin is fairly fundamental to many, let's say, more data-driven or fairly advanced types of text analyses. So a lot of topic modeling methods, for example, the meaning extraction method or the latent Dirichlet allocation method, the foundations of these types of methods are document term matrices, essentially mining texts for patterns of word co-occurrences in some form or another. And so this is a fairly powerful plugin that's going to give you output that you can use for lots of different types of purposes. Now, an important part of this plugin is that we need to have a frequency list first. We need to have a baseline set of information about our texts so that we know which words to include in the document term matrix. Now, for this example, we're going to be looking at a corpus of TED Talks that I have. So these are just transcripts of different TED Talks. And what we're going to do ultimately is create a table where all of the documents are the rows of the data set, and we'll have different words for the columns of the data set. Now, in order to do this, we need our frequency list. And I'm not going to go into too much detail here. I'm going to move through the frequency list part fairly quickly. If you want to know more about it, there's a tutorial here. And a lot of the decisions you'll make when you're making your frequency list are going to depend on your data set, the types of analyses you want to do down the road. If you have questions about this, of course, feel free to send me an email, leave a comment on the video, and I'm happy to help guide you through the process. For now, what we need to know is that we need to load up our texts. And we're going to want to go ahead and tokenize the text and do a little bit of additional pre-processing. We're going to remove stop words from our texts, so we want to leave out really common words. I'm going to load up my own custom list here. And let's also lemmatize this. So we're going to simplify the word lists considerably. And we'll make sure this is in English. And for now, let's do just single words. You can also do bigrams, trigrams, and so on, so higher word phrases. Just know, and this is a very important point, that if you're going to do anything higher than unigrams, you'll want to leave this box unchecked. Now that's true specifically when we're planning on using the document term matrix plugin. If all you're doing is calculating a frequency list, you can use this at your leisure. And for now, we're going to go fairly liberal with some of these values, and it doesn't really matter too much for this example. These are decisions that you'll want to put a lot more thought into for your own data set. And again, I'm happy to help guide you on some of those decisions. And we'll save our frequency list output as FL. Now I'm going to go ahead and run this. And this is going to go fairly quickly, and it's going to generate a frequency list. And assuming I didn't make any mistakes, we'll be able to look at that frequency list here momentarily. And you'll be able to see what's in there, and this will help us understand a bit of the specifics when it comes to using the document term matrix plugin. So we're almost there, 70%. So close. Success. Now let's go ahead and take a look at our frequency list from these TED Talks. And this is fairly intuitive. Notice that there's a lot of words that aren't in here, so because we used our stop list, because we lemmatized, we made some smart pre-processing decisions, so we don't have words like the and a and for loading up here very highly. For the most part, we just have content words that are meaningful. So when we make a document term matrix, in theory, we could make a matrix that includes all however many words are in this data set. A vocabulary of about 18,000 different words or so that occur at least 5 times or more. We don't need to go that hardcore. Most of the time you'll want to do, depending on the size of your data set, maybe the 500 most frequent words or 1,000 most frequent words. Sometimes you may want to go nuts and go up to 3,000 or 5,000 if you have a really, really large data set. Generally speaking, from a psychometric perspective, and this doesn't necessarily apply to people who are working in computational linguistics, we want to follow the rule of about 10 observations per additional word that we extract. Now, we won't worry about that too much here. These are not hard and fast rules. For this example, we have got maybe about 2,000 TED Talks or so. So I'm going to say maybe we'll extract the top 200 words, something in that ballpark. Or alternatively, we can look at this column and say these are the percentage of texts in our data set that each of these words appears in, given the other criteria that we set in the frequency list plugin. So often we may also say, well, we want to extract all words that occur in maybe 10% of texts and above, or 5% of text and above. So in this case, if we did 5%, well, that's a lot of words still. We might pull out something around 1,500, 1,600 words for a document term matrix. Again, these are decisions that you'll have to make based on the size of your data set, the nature of your data set, for example, how long your average text length is, and so on. And we're not going to worry about that too much here. So let's go ahead and actually build a document term matrix now that we have our frequency list. So the first thing that we can do is tell it where our text files are. We'll want to tokenize our texts because this takes tokens as input. So we'll tokenize, and then we'll choose the document term matrix plugin. And then we'll set where we want our output to go. I'm going to name this file DTM for document term matrix. Let's go ahead and go to the settings of this plugin and really dig into what we want to do here. So there's a lot of options, and for the most part it's not as complicated as it looks. We need to tell it first where is that frequency list file that we just extracted, and we can choose that here. And if you have a frequency list from another data set that you want to use, that's okay too. You can also extract all of this in one run, so you can start one chain that does a frequency list like we did before, and then do a second chain that does this process. But we're doing it separately now. We're just going to use that frequency list that we just pulled out. If, when you made your frequency list, you use different CSV settings, you can change those here. Now this is the important part. Do we want to retain n-grams based on what? So we talked about how you can choose to retain n-grams that appear in greater than or equal to X% of documents. If you remember, that would be that observation percent column. So essentially we can set a number here that we use as a cutoff. So anything above, if we said, let's say 10%, Anything above 10%, we would extract that and put it into our document term matrix. Now we can also just look at raw frequency. So we can say any words that occur at least 100 times in our data set, we want to keep those. Or we can look at the most frequent. So let's say we want the 100 most frequent n-grams if we sort by observation percent. So in that case, if we sort this descending, then we would just take the top 100 words, and you can see that would take us down to about here. So these 100 words would go in our document term matrix. And similarly, there's the X most frequent n-grams by raw frequency. Conceptually, that's the same thing, but we would be sorting by frequency. So the top 100 words by frequency is what would end up in our document term matrix. There we go, top 100 words. Now for this example, I'm just going to go with the default options, which is going to pull out all words that appear in at least 5% of the documents. Now this is another important option, the n-gram weighting method. So by default this is set to binary or one hot. This will simply tell us for each word, does it appear in a document, yes or no. 1 is yes, 0 is no. Raw frequency gives us the actual count, the number of times that each word appears in each document. Relative frequency is percentages, so what percentage of each text is comprised of each word. And TF-IDF, also known as term frequency inverse document frequency. This is yet another weighting method. I won't go into it here. You can Google that and figure out what that is fairly easily. So let's just use the binary or one-hot method for now. So let's go ahead and run this, and what it's going to do is load up our frequency list, figure out what words in our frequency list appear in at least 5% or more of all documents. And then we're going to go through each text and scan it for the words that meet that criteria. And this may seem a little bit abstract at the moment, but in a second when we get the results, you'll be able to see what this looks like and what it is that this plugin is doing. So when we open up our document term matrix here, we're going to see that the rows, each row will correspond to one of the texts in our data set, and each column corresponds to a word. So these are all of the words that we decided to pull out. And what these values tell us, for each text, does this word appear in this text? Yes or no? So does the word people appear in this text? Yes or no? And it does not. And we can see there's only 6 tokens in this text, so most of these are going to be no. In this text, we see a lot more ones showing up. So the word people does appear in this text. The word laughter does appear in this text, and so on. Now I'll also note that here we're not doing any of the additional things that we've done before. If we want to get even more accurate numbers, then we would also want to lemmatize these just like we did when we pulled out the frequency list so that we get higher correspondence. However, you can see we're still getting a lot of the same information here. And so this is our document term matrix. Let's go ahead and rerun this, but we'll change a couple of settings just so you can see how that impacts what the output looks like. So this time, let's be even more sophisticated. We will go ahead and lemmatize our texts. So now we're reading the texts, we're tokenizing them, but we're also lemmatizing them. And we're doing that because that's what we did when we extracted our frequency list. And for the document term matrix, we're going to keep using the same frequency list. But now let's look at raw frequency. And let's extract the, let's say, 500 most frequent words. So what this is going to do is it's going to look in our frequency list, and using this column, it'll choose the 500 most frequent words. And then it's going to scan through each text and tell us how many times each of those words appears in each text. So let's go ahead and run this. And this should also go fairly quickly once again. And once it finishes, we'll go ahead and run a quick example of another type of analysis that you can do on this type of output. So we'll do a very computationally simple topic modeling analysis of this TED Talks data. Almost there. Now if we open up this document term matrix, we can see for the most part the structure is the same. We should have roughly 500 words here, so we do. So we pulled out the top 500 most frequent words. And for each text, it tells us how many times did that word occur in that text. So this is a document term matrix, and in particular this, looking at the raw frequencies of each of these words, this is a very standard data set that you would use for something like a latent Dirichlet allocation. In our case, we're going to do the meaning extraction method, so we'll just do a principal components analysis on this data set. And here I have a PCA script that I've written for R just laying around. I'm just going to go ahead and run this. I set it up ahead of time so we have the right folder selected, we have the right output selected, and this is simply going to run a principal components analysis on our document term matrix. Let's see if that actually worked. So if we look at the loadings here, what we'll see is we have 10 different components that we extracted, and if we sort these should roughly correspond to some kind of a theme or topic or style of talking, for example. So you can see here, this is clearly a kind of political / economic theme that is loading on here. Country, state, unite, economic. Here we have a very clear, perhaps ecological or natural sciences theme, words like Earth, ocean, planet, sea, species, these are all clustering together. And using a principal components analysis, this just essentially tells us which words form clusters when we look at an intercorrelation matrix. Other types of analyses use very different statistical and mathematical approaches, but you can see it works fairly well. If we want to summarize our data set, what we can do is we can extract a frequency list to look at the most common words. Based on that, then we extracted our document term matrix, and then we reduce that document term matrix space. We crush it down using a principal components analysis, and that tells us this information about kind of these fuzzy topic spaces that exist within our corpus of text. Now, of course, you can use that document term matrix and do any number of analyses with it. It really is the foundation of a lot of basic natural language processing techniques. And that's it. That's how you use the document term matrix plugin for the Butter text analysis software.